Now that we've talked about proteins, we're going to focus on a group of proteins called enzymes. Most enzymes are proteins, and they are catalysts. Their job is to speed up a chemical reaction. Chemical reactions require a certain amount of energy in order to occur. Sometimes this amount is too great. So, an enzyme brings together the reactants and thereby speeds up the reaction by lowering the energy required, also known as the activation energy. Enzymes are not permanently changed in the process, and they're not used up, but can actually be used over and over again so that the reaction continues to happen without slowing down. Think about chewing the saltine. If your saliva did not have the enzyme amylase, breaking down the starch in the saltine would have taken a really long time, if it had been possible at all. And if amylase was not reusable, you would have had to make a lot more saliva than you did. As I recall, there was many a dry mouth in the room as your saliva was absorbed by the cracker. It could have been even worse. Enzymes are very specific for what reactions they will catalyze. The compound that they act on is called its substrate. Generally, the enzyme's name is very similar to its substrate's name, except the enzyme ends in ase. For example, sucrase acts on the disaccharide sucrose, lactase acts on the disaccharide lactose, and maltase acts on the disaccharide maltose. Proteases are another category of enzymes that break down proteins. The place that the substrate interacts with on the enzyme is the active site. These are specific the way a lock is specific with the key that will open it. Here is an example of the after reaction state. Hydrogen peroxide was the substrate. The enzyme was peroxidase, isolated from the liver. The tube on the left shows the enzyme without its substrate. The tube on the right shows what happens when the two are mixed. The result of the reaction is oxygen being given off, as can be seen by the bubbles. There are three factors that will affect enzyme activity. They are environmental conditions, cofactors and coenzymes, and enzyme inhibitors. For environmental conditions, like all proteins, enzymes are sensitive to changes in heat, pH, pressure, and ionic changes. Extreme changes in their environments away from the conditions that allow them to work best will cause a structural change in the enzyme. As we experienced with the tubers and changing a specific amino acid, this results in a folding change for the enzyme. Usually an unfolding is the result. And now the active site will have the wrong shape so that its key, the substrate, will no longer fit or bind. Cofactors and coenzymes are exactly what they sound like. The prefix co refers to things being together. Coeducation refers to educating boys and girls together in the same classroom as opposed to being at separate schools. If an enzyme requires a coenzyme or cofactor, it will not work without it present. For example, iron must be present in hemoglobin in order for it to transport oxygen. Finally, we will look at things that will inhibit or stop enzyme function. There are two classes of inhibitors. The first are competitive inhibitors. These are chemicals that resemble an enzyme's normal substrate and compete with it for the active site. In a competition, you are going against your opponent for the same end goal. A competitive inhibitor then will bind to the active site of the enzyme and prevent the substrate from binding. A non-competitive inhibitor still prevents the substrate from binding, but this time it is by attaching to a different spot on the enzyme. When it binds, it changes the folding shape, the quaternary structure of the enzyme, so that its active site is no longer the right shape. Again, think about a lock and key. If the shape of the lock changes, the key will no longer fit into the lock.